Right now we're going to talk about section 6.3, and section 6.3 is all about polar coordinates. You can see we're going to use these polar coordinates to graph, and we're going to come up with pictures like the ones shown here on the first screen. So it's a lot different than the graphing we're used to. Now, we're going to need to know a little vocabulary in order to figure out how to plot these graphs. You'll notice if we move forward for 1 second that our axis is no longer a normal XY axis. We don't have a regular grid that we're graphing on. We're actually graphing on a unit circle here with lots of circles. If we go back now and look, the points are no longer in XY form, they're in R theta form. R is going to be the radius of your circle, and theta is going to be your angle. Now that angle can be in degrees or it can be in radians. The polar axis is a ray. It's like the initial side of our angle, and you can see that the pole is the end point of that initial side, kind of like the origin on a normal graph. When you plot these points, though, you don't plot the whole ray, you actually just plot the final point. You'll notice a statement down here about when your radius is negative. When your radius is negative, the point is going to end up opposite the terminal side of the angle. So you'll plot it as if it was positive, and then you're going to flip it to the opposite side. You'll see some examples of that in just a minute. Let's go ahead and start graphing some of these, and so we can get the idea. We want to plot the following points, and we'll start with that 3 pi over 4. Now, you're going to want to grab your polar grid. Yours may or may not be split up in pi over 4s and pi over 3s, so you might have to check to make sure that you have all the correct spots on your grid. And we're going to graph the first point here, 3 pi over 4. Now the place you're going to want to start is actually with this pi over 4. You're going to want to start with the angle. We're going to find pi over 4 on our unit circle, and that ends up right here, that line right there is pi over 4. Now I start in the center, and I'm going to go out 3 spaces from there, 3 radiuses. So here's 1, 2, and there's 3. And that would be my final point in there. We'll erase the rest of this because we don't need it. So that would be the point 3 pi over 4. Let's take a look at the next one. You can see this one's in degrees. So we're going to go to 135 degrees, and that's over here at 3 pi over 4. And we're going to go out 2 radiuses. So we're going to end right there. And we can erase those little loops. And that's going to be the 2 135 degrees. Now the next one has a negative radius. So this is going to be an example of one where we're going to have to flip to the other side. We're going to start by going to 3 pi over 2. So 3 pi over 2 is down here. Now, we're going to go out 3 radiuses just like we normally would, and we're right over here. But now we're going to flip to the other side. We're going to flip up and down. So we're going to flip up top here, and it's actually going to end up here at pi over 2. So this would be the point negative 3 pi over 2. You'll notice that we had to flip it over to the other side because of the negative radius. You could also think of it as, once you get to that the 3 pi over 2 spot, go the opposite direction 3 units. We'll graph the last one here in black. Again, start at your angle. Now the angle's negative, so I know negative pi over 4 is down here. The radius is also negative. So instead of going 1 in this direction, I'm going to go, I went 2 there. Instead of going 1 in the positive direction, I'm going to go 1 in the negative direction. And I'm going to end up right over here. Notice it's on that same line. And so that's the point -1, -pi over 4. All right, it's going to be really important that you have the hang of plotting these points. So I'm going to go ahead and give you a couple to try now. And you're going to try these, and we'll go over them tomorrow when you get to class. All right, now unlike an XY axis, when you have a point XY, that's the only way you can have that point on the graph. There's never multiple representations of the same point. In our polar axes, it's a little bit different because you can go around and around and around the unit circle many times. Let's visualize an example for a minute. If I think of the spot pi over 3, if I add 2 pi to that, I get 7 pi over 3. Now, no matter where I am, how many radiuses out, if I go pi over 3 or 7 pi over 3, you can see those will both represent the same dot, the same point. So by adding and subtracting 2 pi's, we can change the points the way they look, but you'll see they end in the same spot. Let's look at an example. I want to find another way to represent the point 2 pi over 3. Now, the first way is that I want it to stay a positive radius. So really, that's just the idea we were talking about, where I just have to take my angle and add 2 pi more. So here's an example right here, where all you have to do to get the next point is add 2 pi to theta. So let's see, if I take 2 pi over 3, but I add 2 pi to that theta, I'm going to get a bigger angle that's going to be in the same position. Now, I want to change 2 pi to be a third, so we're going to change this to 6 pi over 3 to have common denominators. And I end up with the point 2, 7 pi over 3. Now 2, 7 pi over 3, and 2 pi over 3 are exactly the same. They end in the same position. Now, I want to change it just a little bit. I want an example where my radius is now negative instead of positive, and I still want to stay between 0 and 2 pi. Now think about it for a minute. If we think about where this is at, the original point 2 pi over 3 is right up here. If I want the radius to be negative, it means it's going to flip to the other side. So I have to add a total of pi units to my angle, or 180 degrees. That's what's getting it to flip to the other side. So in this case, I'm going to take my radius of 2 and change it to be negative. But then I have to take my angle pi over 3 and add pi to it, because I'm going to get it to flip to the other side. Now pi is 3 pi over 3. So we end up with the point -2, 4 pi over 3. And you can see it's another way to represent the same thing. We're not going to worry about this last one. So both of these are 2 ways to represent the same point, 2 pi over 3. I want you to go ahead and try this last one, and we'll go over it tomorrow. And this is where we're going to end for today.